Welcome, everyone. I'm excited to kick off our presentation today. We're going to explore operations on rational numbers. This is the first slide, so I just want to briefly introduce what we'll be covering. We'll look at different ways to work with rational numbers, including addition, subtraction, multiplication, and division. So let's get started and dive into the fascinating world of rational numbers. Let's take a quick look at the contents of today's presentation. We'll start with an introduction to rational numbers, then move on to explore the properties of their addition, which is fundamental to understanding how they work. After that, we'll discuss how rational numbers are multiplied, followed by examining the concept of rational numbers lying between two others. We will also cover the properties involved in subtraction, and finally, look at how division of rational numbers operates. Each of these topics builds on the previous one, helping us develop a comprehensive understanding of rational numbers and their behaviors in different mathematical operations. Today, I want to share a little story about two children representing different types of numbers, whole numbers and rational numbers, having a friendly chat. The whole number child asks, "Do you know that rational numbers, like me, can be acted upon by different operations such as addition, subtraction, multiplication, and division, and that these operations follow certain properties?" The rational number responds, "But brother, I'm not quite sure how these operations work on me." Maybe we should ask our teacher for some clarification. Now the teacher steps in and says, "I'll be happy to clear up your doubts, but first, let me ask you a few questions." The teacher then asks, "What is the additive identity for whole numbers?" This is an important concept because the additive identity is the number that, when added to any number, leaves it unchanged. Here, it's 0. Next, the teacher asks, "Can you define the distributive property of multiplication over addition?" This property is fundamental because it explains how multiplication distributes over addition, meaning at times the sum of two numbers equals the sum of the products. Then the teacher inquires, "Does the whole number obey the commutative law under subtraction?" This is a trick question because subtraction is not commutative, highlighting that the order of numbers matters in subtraction. After these questions, the teacher moves forward with more, asking, "Can you say two whole numbers between 5 and 12? This helps us understand the range and the application of whole numbers in everyday numbers. The teacher then asks, "What is the multiplicative inverse of 5? Which is the number that, when multiplied by 5, results in 1, emphasizing the concept of inverses in multiplication?" Finally, the teacher asks, "Tell me whether division obeys closure property or not." This is key because closure tells us if the result of an operation stays within the set, and division does not always do so within whole numbers. Through this conversation, we see how these properties and questions help us understand the fundamental nature of numbers and their operations, a core part of our overall theme of exploring the properties of different kinds of numbers. Now let's explore rational numbers. Can you say why 0 is considered a rational number? Well, just like whole numbers, rational numbers are very flexible because they allow for 4 basic operations. These are addition, subtraction, multiplication, and division. Each of these operations helps us understand how rational numbers interact and combine. Remember, the key idea here is that rational numbers, including 0, can be used in all these operations without any issues, which makes them very important in mathematics. Connecting this to our overall theme, recognizing the properties of rational numbers helps us build a solid foundation for more complex concepts ahead. Now, let's talk about the properties of addition of rational numbers. Specifically, we're focusing on the associative property. This property tells us that when adding 3 or more rational numbers, the way we group them doesn't change the sum. In other words, whether we add the first 2 numbers first and then the third, or group the last 2 first, the total remains the same. This is a key idea because it helps us perform calculations more flexibly. It also connects to the overall theme of understanding how rational numbers behave under different operations, making our math work more consistent and reliable. So remember, the associative property is all about the flexibility in grouping during addition. Now, moving on to the properties of subtraction of rational numbers. One important thing to keep in mind is that, unlike addition, subtraction of rational numbers does not satisfy the associative property. This means that if you have three rational numbers, changing the grouping when subtracting them can lead to different results. For example, subtracting in one order versus another can give you a different answer, which is quite different from what we see with addition or multiplication. Understanding this helps us avoid mistakes when working with rational numbers, especially in more complex calculations. It also highlights that subtraction behaves differently and requires careful attention to the order of operations. So remember, the associative property doesn't hold for subtraction, and being mindful of this is key as we continue exploring rational numbers. Let's dive into the multiplication of rational numbers. When we multiply two rational numbers, the process is quite straightforward. First, we multiply the numerators together to get the new numerator, and then we multiply the denominators to find the new denominator. It's important to remember that the result is also a rational number, which means it can be expressed as a fraction where both numerator and denominator are integers, and the denominator isn't zero. One key point to keep in mind is how signs work in multiplication. If both numbers have the same sign, either both positive or both negative, the product is positive. If they have different signs, the product will be negative. This rule helps us quickly determine the sign of the answer without doing the full multiplication first. Another important aspect is simplifying the resulting fraction whenever possible. Simplification makes the answer easier to understand and compare with other rational numbers. Connecting this to what we've discussed earlier, multiplication of rational numbers is fundamental because it extends our ability to work with fractions in more complex calculations, whether in algebra, real-world problems, or science. It's a powerful tool that, once mastered, makes working with rational numbers much more intuitive and efficient. Let's take a closer look at the properties of multiplication of rational numbers. First, the commutative property holds true here, which means that the order in which we multiply two rational numbers doesn't change the product. So, whether I multiply a by b or b by a, the result remains the same. This shows that rational numbers obey the associative property as well, meaning that when multiplying three rational numbers, the way we group them doesn't affect the final product. For example, a times b times c is the same as a times b times c. Now, moving on to the identity element, remember that one acts as the identity element in multiplication. Multiplying any rational number by 1 leaves it unchanged, which is a fundamental concept in multiplication. Also, a quick, important point. If we multiply any rational number by 0, the product is always 0. 0 has a special role as the absorbing element in multiplication. Next, let's discuss the distributive property. When we multiply a rational number by a sum or difference, it distributes over addition or subtraction. This means that a times b plus c equals a times b plus a times c, and similarly for subtraction. This property is essential because it connects multiplication and addition-subtraction in a very logical way. And as we can see from the calculations on the slide, the left-hand side equals the right-hand side, confirming that the distributive property holds for rational numbers. So, overall, rational numbers obey these key properties: commutative, associative, identity, and distributive, which help us understand and simplify many algebraic operations involving rational numbers. Now, let's move on to the division of rational numbers. When we talk about dividing rational numbers, it's important to remember that we're working with fractions, which are ratios of two integers. The key point here is that dividing by a rational number is quite similar to multiplying by its reciprocal. For example, if you have a fraction and you want to divide it by another fraction, you flip the second fraction and multiply. This is a crucial concept because it simplifies the process and helps us understand the relationship between these numbers. Also, keep in mind that dividing by 0 is undefined, so we always need to be cautious about that. Overall, understanding how to divide rational numbers connects to our broader theme of mastering operations with fractions and rational numbers, making calculations more intuitive and accurate. Let's talk about the properties of division of rational numbers. First, It's important to note that the associative property, which we often see with addition and multiplication, does not hold true for division. That means if you have a division expression, changing the grouping of the numbers can lead to a different result. So, you can't just rearrange the parentheses and expect the answer to stay the same. Next, when we look at the equality between the left-hand side and the right-hand side, LHS equals RHS. But this equality doesn't rely on the associative property because division isn't associative. Finally, the distributive property, which allows us to distribute multiplication over addition or subtraction, also does not apply to division. You can't distribute division over sums or differences in the same way. Understanding these limitations helps us avoid common mistakes and deepens our grasp of how rational numbers behave under division. It connects back to the overall theme of recognizing which properties hold true and which don't when working with different operations. Now, let's wrap up by talking about the rational numbers between two rational numbers. First, we revisited the concept of rational numbers, understanding that they are numbers that can be expressed as a fraction. Then, we looked at the properties involved when we perform operations like addition, subtraction, multiplication, and division with rational numbers. It's important to grasp how subtraction and division behave, as their properties help us understand the relationships and the structure within rational numbers. We also explored how we can find rational numbers that lie between two given rational numbers, which is a key concept in understanding density in rational numbers. Remember, the operation of rational numbers is fundamental, and knowing their properties helps us manipulate and compare them effectively. The idea of inserting rational numbers between two others highlights the dense nature of the rational number line, meaning there are infinitely many rational numbers between any two rational numbers. Overall, these points connect to the broader theme of understanding the structure and behavior of rational numbers, which is essential in mastering number systems and their applications.